All right, now we're ready. Check, 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 check. I should have a physical checklist that I go through every day. One day I'll forget something. Okay, so my ideal plan was to save Fridays to work through kind of our stuff, but I kind of slipped behind. So I want to just quickly work through chapter 3 and just introduce some of these common graphs that we would use. And then next week, I'll show you how to actually generate some of these graphs. Some of them are more complicated, and so we'll kind of parking lot those for a little bit, but I'll just show you the core. For rhyming reasons, let's call them the core 4. I don't know which ones those are yet, but I'll show you some of those core graphs, how to generate them in R. But you can also Google your way to it in the meantime. But first we have to have the terminology. What are these? When do we use them? And so on. So I posted the chapter 3 summary notes. And again, I keep going back and forth, changing stuff, removing stuff, adding stuff. I've landed on this. We'll see how it goes. See how I like it. So data visualization is, of course, a huge component, especially if we're working as an analyst, right? Usually we are producing these documents and handing them over to a boss, right? So someone else is going to use that information to make decisions, draw conclusions, that kind of thing. Hire people, fire people, right? Big decisions. So what we have to do is effectively communicate information from the data, right? And so that's what a data analyst does. Okay. So the most common way to do that, remember, whoever your boss is, they don't want to be dealing with this stuff, right? They just want to look at some report. Usually they like it a one-page report, a dashboard, but usually they just want to be handed a report and they can just look at that and just get information and move on with their lives, right? We've spent weeks upon weeks upon weeks working on this stuff, and then it's very anticlimactic. Oh, thanks. Okay, yeah. And then they're done. Oh. Right. And so the most effective way to do that is to show visualizations, right? There are cases where maybe a table with just values is more useful. So I want to talk about that as well. But so data visualization, we have different flavors, right? And so I might have a certain preference. I'm going to outline what's in the textbook because they are published. And so, of course, their opinions are kind of better than mine, I guess. But for me, I have some other preferences that I have developed. For example, remember in the, I think it was in the first chapter, they had a big table of stuff, and I just found it was hard to read across because there were so many rows and columns and everything going on. And so I would have liked to see some sort of breaks in there, right, to help my eye. Whereas they're saying, no, none of that. So it's just a matter of preference. Okay, and so let's see here. I guess I didn't even read the, anyways, I basically said it all. It's taking forever to do what I tell it to do. So one pretty cool dude is Edward Tufte. He is the kind of founding father of typesetting. And so he's developed, he's written books, and he developed LaTeX, or he was part of the crew that developed LaTeX, which is a typesetting language. And he's just kind of the go-to guy for typesetting. Now, typesetting, right, used to be how should we organize a textbook, or how should we organize any book or written document for it to be the most readable, so readability. So his thing is just how can we concisely deliver information to a reader? And so he developed this idea of the data ink ratio, and it is something to keep in mind, right? So there's in a graph, you're going to have what we call data ink, right? Ink that is representing data, right? So in a scatter plot, the data ink would be things like the points on the scatter plot. And maybe I have an example here. Maybe, just maybe, I do, right? So here, if we have this graph, for example, just typical kind of graph, right? And so with a little bit of kind of teasing out information here, the data ink would be things like, so the data ink would be these points. Dun, 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 dun. Okay. Potentially the lines connecting them. I don't typically think that they're that important, but it does help for us to see kind of the trend of this data as we move across the x-axis. Okay, and so here we've got the sales. So what we're looking at is the sales, presumably number of sales. It doesn't really matter what this is. This is just a general example, right? And so the fact that we're talking about the sales, I would consider to be data ink, right? Because that's something that we are producing from the data. Things like these lines, right? Those would not be considered data ink. And so, and even the axes here, I don't think they consider them data ink. And so here, when we have all this ink that didn't come from the data, right, versus the little bit of ink that came from the data, that would be kind of a bad graphic in his kind of data ink ratio idea. Okay, and so I'll put that here, and then I want to show you, oops, not the same page again, but this one here, copy. So now, when we look at this one, right, we notice that it's the same information, right? And it's been clarified quite a bit. Right, we've increased the amount of data information by including that this is the day, right? That actually wasn't clear here, right? We had the axes, but then we didn't know what it was, right? And so there's something missing from the data. Here we have on the y-axis, we have the sales units. And so that's been transferred from over here where it was just kind of sloppy, right? And so we should have axis labels, of course, and that's pretty basic stuff. I think I remember kind of maybe chemistry or 11 or something like that, where you had to make graphs. Sounds insane, right? But we had to make graphs. And then it was so important that we had to label the x-axis and the y-axis, right? So this isn't news to us, right? We should label our axes. And here, they've removed these lines because they felt that they weren't that important. However, I would argue that if there is some sales threshold that we're interested in, right? So let's just assume that 200, that's some sort of sales threshold, right? Maybe you get an award or you don't get an award, right? That kind of thing where we're making a decision based off of the sales, then maybe it might be useful to have a line on a slant. No, should be straight across, but I'm not very good at drawing. Right. Then we might have some sort of line on there. That would be okay, right? Because it's helping us learn about the data, right? So I would kind of lump that in with the data ink ratio. Okay. Good. So these are just kind of general ideas. Sit back, relax, and learn. All right. So I do want to mention here what I did. If 200 sales is meaningful to the decision maker, that's typically not us, right? If you want to be the decision maker, you're in the wrong field, because we just present information. We might make recommendations, but usually we're just presenting information and then someone else takes it and runs with it, right? So it's kind of a background role. But if 200 sales, for example, is meaningful to the decision maker, we might include it in the graph. Maybe that's where we break even or something like that, right? So then you could include it, but they're saying you don't need to have all these individual lines. And I agree with that. It makes it look a lot cleaner when there are no lines, right? But maybe there are instances where one line or two lines might be useful, right? We're always going to have to be a little bit flexible. There is no cut and dry rules for how we should be presenting data, right? So tables are useful, but they're a little bit hard to read sometimes, right? If I just give you a table with tons of information in it, unless you know what you're looking for, that can be really hard to wrap your head around, right? And so let's just put tables here, and then I'm going to bring in an example of a table as well. We do have to use tables. Come on. Copy. Okay. So a table like this has summarized a lot of information. It's summarized the head count, the cost, the revenues for some random business by month, 1, 2, 3, 4, 5, 6, right? And it's also got the total. So there are instances where we might be interested in the cost versus the revenue. Then we don't want to be talking about approximate costs, right? And approximate revenues. We probably want the actual value, right? And so especially if we're reporting for tax reasons, right? Or kind of year-end quarterly reports, then we probably want to have the actual numbers, right? Not just rounded values. So that's one of the instances where we should be using tables instead of a graph. Now, if you're only interested in, relative differences, so the sales from one store to another, maybe, right? How do they relate to each other? Then you could consider just giving a graph, because then the actual numbers don't matter, right? Was it 22 more in sales or was it 23 more in sales? Well, it doesn't really matter. We can just get a glimpse from the graph. So I've got a graph here that shows you what I mean. Okay. So for example, right, if we're looking at the revenues versus the costs, okay, for each month, then we can have a dotted line for the revenue and a solid line for the costs, right? So here in month 1, our costs were a lot lower than the revenue, right? We can't gather from here how much lower, right? But it's easy to see when I look at this graph, it's easy to see that in month one, the costs were lower than the revenues, right? And that's a good thing, right? That's probably where you want to be. Month two, we can tell that in comparison to month one, right, the distance between those two, ouch, is a little bit less, right? So our costs are still lower than the revenues, so that's good, right? It means we're making money, but it's slightly lower than month one. Notice how we can't, and we won't attach a value to it. We can just say in relation to, so the costs in relation to the revenues, how they relate, right? And then we can say that it was in month four that our costs actually started to exceed the revenues by a little bit, right? And then that held steady for month five, and then we were back to the costs being lower than the revenues in month six, for example, right? If we needed to know the actual differences in the costs and the revenues, then we would need to have a table, right? And so it depends on the information that you want to show or that the decision maker needs, right? So graphs show relative differences okay, but for exact differences we would use a table. But for exact differences, we should include a table. Okay. So going back up to the blurb, okay, the first decision in displaying data is whether a table or a chart. So a chart here, they use the word chart, and I feel like I mentioned it earlier, but a chart is a graph, is a plot, right? So we use those terms interchangeably. I tend to call it a graph most of the time, but they like to call it a chart, so that's fine. So, but the key thing to remember is which one is more effective, right? And which one is more effective depends on what you need to be talking about, right? How do they compare, or what's the actual difference? That depends. So in general, charts can often convey information faster and easier to the readers, right? We can quickly look at that graph and have a good understanding of what's going on, right? Whereas if I only gave you the table, that would take some work, right? If you just looked at this table down here, right? Well, let it catch up here. For your mind to go 48 to 64, okay, so the costs were less than the revenue. Okay, so I made money, right? That's a big kind of, that's a lot of work that your brain has to do, and it's not obvious, right? 56 to 66, okay, I still made money. 64 to 67, I made money, but less money, right? 52 to 48, hold up, no, that's bad, right? And so we can do it. It's just easier with the graph, right? So that's how we decide what's more effective, right? Both of them do it. So tables should be used when the reader needs to refer to specific numerical values. So think of a tax return, for example. The CRA is not that happy if you just say, oh, approximately this much. No, they don't like that, right? And so then you need specific values, right? If the reader needs to make precise comparisons rather than relative comparisons, right, then you should have a table and potentially as well as the graph, right? If you're comparing things that have different units, right? In the example that we've been looking at, we've been talking about dollars to dollars, right? Costs and revenues. So those dollars units are the same. So we can compare them easily. But if they have different units or even different magnitudes, right? So being in the tens versus being in the hundreds is what I mean by magnitudes, right? If they have different units is usually how it goes, then we should use a table instead to kind of look at how numbers are changing. So one example of that is this guy here. Wow. If we're looking at the head count now on top of the costs and the revenues, right? Because maybe we suspect that the head count is contributing to maybe the costs or potentially, hopefully, the revenues, right? And so here, now head count is just 1, 2, 3, 4, 5, and it looks like it maxes out around 10, whereas our costs are in the tens of thousands, right? 48,000, 64,000 for our revenues, right? And so those magnitudes are really, really different. So then we shouldn't have them on the same graph, because then you'd have to have a whole new axis for your head count, and it just doesn't make sense. Okay. So just kind of things to keep in mind, I guess, when you're deciding what to do. In terms of kind of design principles, this textbook prescribes to the fewer lines, the better. There are some rules where we need some lines, and I'll show you the example that they have here. Okay. And so we should use horizontal lines. Maybe it makes more sense to talk about it here for a second. Okay. And I always struggle with horizontal and vertical, as was obvious there, right? But horizontal is like this because you've got the horizon like this. So horizontal, vertical. Okay, so horizontal lines, we generally only need them to separate the column titles. So the variable names typically, or just the column titles, from the actual data values, right? Potentially, if you've done a calculation at the bottom, then you may have a horizontal line at the bottom as well. But typically what they're saying is that we don't need a ton of lines inside our table, right, in order to make it readable. So what they're saying is that you really only need one horizontal line like this to separate the headers from the actual data, right? And then what they're saying is that you need a vertical line at least to separate if you've done some sort of calculation. So that's what I mean by, if I had done a calculation down here at the bottom, that might be the costs minus the revenue, or maybe the revenue minus the cost to see how much money I made. Then I would have a line here to show that, okay, now I'm doing the revenues minus the cost, right? So then I would have a line to show that I'm doing a calculation, right? And so very few horizontal lines, fewer the better in their opinion. I actually kind of like, so if you look at these designs, they've given us a couple of designs to consider here. Why is it all blurry still? Anyways, get the gist. Design A has really thick, bold lines for every single cell. I don't love that because it looks really cluttered, right? And the thick lines kind of make me stop reading, I guess. Design B is the one that I kind of like. And I know that's bad. They just told us the fewer lines, the better. But I don't know. I still like design B. But they claim that most people are going to gravitate towards design D, which, you know what? Maybe they're right. There may be some truth to that. Right? It looks good. And so here's the example that I was talking about. If I wanted to talk about how much money I made or the profits, that's the revenues minus the cost, right? And so I would separate that with a line. Okay, so tables, right? Sounds like we were building up to something when I made you build a table, just a blank table for your most recent assignment. Method to my madness, I guess. Eventually we'll fill it with stuff. Okay. So in large tables, and I'm not going to bring this one in, but it is here in the notes. So in large tables, then we could use something like shading, right? If we want to highlight how things have changed from month to month, for example. Whereas if the concern is more about changes between each location, it looks like here, then we would have shaded the rows instead, every other row, to help us read across the rows. So it depends on what we're most interested in. Okay. Here, I want to use this one, this table, to talk about, hey, it keeps alignment. Just force it on a fresh page. Okay. So consider, just because I had to make all that blank space, so I'll fill it with some text. Consider the alignment in the table below. The alignments in the table below. Okay. So what do we mean by alignments? In general, well, there are only 3 alignments that we can talk about. So it can be aligned to the right. Okay. Left, left, right. Here, this section is aligned to the left. I don't know why I said right. Okay. Typically, and there are exceptions, but text is aligned to the left because we don't like to read jaggedy things on the left-hand side. We're okay with it being jaggedy on the right-hand side, but typically we like to have text kind of one on top of the other, right? And so this is typical for text, right? To have it be aligned to the left. And remember, I'm not saying that this is a one size fits all, but it is a general rule of thumb, and it's going to make your graph look good or your table look good and readable most of the time. The next thing I want to mention is all these values in the body of the table and in the totals, I guess. So as soon as we're talking about numbers, we tend to align to the right. And the reason for that is because if they all start to the right, then we can see differences in magnitude, right, quite easily. Okay. And so numbers are often aligned to the right so that we can easily detect changes in magnitude. So that we can easily detect changes or differences, I guess. Changes / differences in magnitude. Okay. For example, if I tell you there's 10 and then there's 110, right? You can see that there's this kind of jaggedy difference. And so that highlights to us that this value is larger than this value. And for some reason, it's harder for our eyes to see it if we have it aligned to the left. So that's why we align things, numbers, on the right. Okay, just in general. To throw a curveball, why not? Typically, the headers are going to be center aligned. They could be aligned to the left or to the right, but in general, we like to have them in the center because it makes things look the nicest. And so here, take it out. Headers are usually aligned in the center. Right. So you'll play around with that and kind of see what you like the best. But as a typical setup, right, text is aligned to the left, numbers, so like data values, are aligned to the right, and then the headers are center aligned. And that's kind of a good rule to play by. Okay, so good. Why not bring this whole thing in? Copy. So we can have what we call a cross tabulation. A cross tabulation requires two variables, right? And we're going to talk about two categorical variables for now, which is the most common for a cross tabulation. And so if we look at this data set, okay, it's the first 10 restaurants for the quality rating and meal price for 300 Los Angeles restaurants. So these keep going. There's 300 restaurants, but this is just the first 10. So we get an idea of what the data looks like, right? So let's flex our variable classification skills here. The quality rating would be a categorical variable, right? And so here, this is categorical. The meal price is actually kind of flexible, and it depends how we might want to report it, right? Just kind of looking ahead, if I look ahead here, they've created categories from that numerical variable or the quantitative variable. So as it stands here, the meal price, I would say, is quantitative. But later made into categories. Okay. And then the wait time is going to be quantitative. Again, we could create categories for the wait time as well, but for now, we're going to leave it alone. Quantitative. Squeeze it in there. Okay, so what we've done is we've created this. Hey, what's going on here? This, now I've done it quantitative. It shrunk up and then I didn't know where it went. So anyways, all right. So the cross tabulation that we're looking at here is, of course, looking at a categorical variable, and then we've created this categorical variable. Likely because it doesn't matter if a meal price was $10 or $12 or up to $19. People kind of feel the same way about this price category. We feel good about it, right? 10 to 19, pretty good. 20 to 29, a little bit, ugh. 30 to 39, you're crazy. 40 to 49, I'm out of here. Right. And so, right, we've kind of decided on these categories where, okay, that's kind of a reasonable breakdown. It is also moving up in tens. So we are moving up kind of in equal segments. That's not always going to be the case, but often it is, just for lazy reasons. When you're creating these categories, you don't want to spend too much time creating these categories. So in terms of reading this crosstab, call it in the biz, this says that, well, we had a sample size of 300. So the 300 here is the total number of restaurants that we've considered, right? And so this 42 here, for example, let me see here. 42 restaurants out of 300, right, had a quality rating of good and a meal price between 10 and 19, right? And so that's information. How useful it is, I'm not sure, but that's how we use these cross tabs, is we're able to look at two categories at the same time. So 42 restaurants out of 300 had a quality rating of good and a meal price between 10 and $19, right? So you could interpret every single entry in here just like that, right? But the whole point of a crosstab is to be able to talk about two categorical variables at the same time, right? And so we use cross tabulations to consider two categorical variables at the same time. Okay. We often have the totals on the outside, right? And so the total for the rows, well, that would be ignoring the meal price rating. So the total number of restaurants that had a quality rating of good is 84 out of 300, right? For very good, it was 150 over 300 and so on and so forth. Or you could completely ignore the quality rating, right? And only consider the meal prices, right? 78 restaurants out of 300 had meal prices between $10 and $19, 118 between 20 and 29, right? And so what we call these marginals, and the joint, eventually they're going to be probabilities, but forget I said that later. Okay, but so you can read the totals and completely ignore the body of the table, or you can read just the body of the table, ignore the totals, or you can get crazy. And what if I asked you how many of the very good restaurants? So now I'm focusing just here on very good restaurants. How many of the very good restaurants had a meal price between $20 and $29? So now the answer would be 64 out of 150, right? And so we can get a lot of information and a lot of different information, and it totally depends on the question that you're trying to answer, right, for your boss. So lots of things we can learn from a crosstab and ask from a crosstab. All right, so in terms of charts, you'll see that there's just very, very brief summaries about what each chart is, right? We've seen some scatter charts already, or a scatter plot is usually what I like to call it. Oh, and I think I mentioned the catter plot, something to look into. Replaces the dots with cats. Cute. I'm gonna dig up that code. It's on GitHub somewhere. I just need to find it. It's only the important things that I remember. Catter plots, scatter plots.
Is that going to be on the test?
Catter plots. Oh yeah, it's so important for business.
Roger.
No, no.
Maybe for bonus marks. Okay, I'll stop. I'll stop encouraging.
Yeah, it's definitely worth bonus marks for sure.
Of course.
So scatter plots, line charts, right? And so we'll go through these, but this is basically all there is until I show you how to generate these. Just knowing what they are is going to be useful, right? So when I say make a line chart, you know that it should end up looking something like this, right? If I say make a scatter chart, scatter plot should look something like this, right? Bar charts or column charts should look something like this, right? So, and I know I'm out of time, so I don't want to start anything fresh, but just have a read through the charts and just kind of familiarize yourself with the names and what they should typically look like, and then we'll start from there. Next day, which I guess is Monday. Oh my gosh, weekend time. If you have any questions, let me know. Otherwise, we'll call it here.
Can I ask questions about the assignment?
Sure. Let me stop this recording first. It'll be our secret.